cannot use it to make beams which have tension. So we are also looking at how we can integrate robotics with concrete 3D printing. So we see whether we can uh, insert reinforcement rods into 3D printed concrete so it can also take tension. So I have a research project in which we are exploring this idea of combining robotics with 3D printing. I'll show this video also. So this is a robotic system we made with to combine 3D printing with robotics, mainly to place the reinforcement rods. So you can see the reinforcement rods are put in an indexer. It is here. And you can see this is a gantry system which moves in the X, Y, and Z direction. So now you can see it is going down. There's a gripper at the bottom. It is picking up the reinforcement rod. Later on, you will be able to see more clearly. We were not able to record it that clearly. So this is coming up. So the gripper has come up. There's a reinforcement rod that is picked up. So it is moving. So we have already 3D printed the wall with a particular profile with cavities. And we want to insert this rebar into the cavity and then fill it with concrete. So it can also take some tension due to bending in the transverse direction. So you can see now the rod is coming down. So it is going into the cavity. And this can actually pour concrete, but we are not pouring concrete because it is quite messy and we want to use the specimen multiple times. So just put sand in the hopper. So it is just pumping the sand into the cavity. So the idea is you put the reinforcement, you pour grout and fill it. So it bonds with the 3D printed, earlier printed concrete, and it can take tension. So this is a demo of what we have done with this integrated Conquer, the 3D printer with robotics. And it can also do a lot of other things. I will show later on another video of a pneumatic gripper, which can take plates and place it. So it's not just a reinforcement rod, it can also place other kinds of objects into 3D printed structures. So it is picking up another another reinforcement rod. So you can see there are two grippers. The one which is gripping the rod is of a particular type. There is another one nearby that is a pneumatic gripper. I'll show a demo of that later on. So it is again repeating the process. Earlier, you were not able to clearly see how it is gripping the rod. But now you can see it, and now it will repeat the same thing. It goes to another cavity and it will place the reinforcement rod in the other cavity. Okay, I'll stop this here. Okay, so you see, we saw this video of the 3D printer and the one with integrated robotics. But now the challenge is how do you determine the operation, the sequence of actions to be performed by the robot? Later on, the earlier somebody had already posed this question. How do you automate the sequence? There was a question similar to that. So that is the biggest challenge. How do you find the sequence of action so that these can be done automatically? So this is a path planning problem, which is very common in robotics. We want to find out the path the robotic gripper or the tool should take. And how do you automatically determine this path? So I pose it as a graph problem. In computer science, there are graph problems using graph theory. So this is a typical problem. So I'm just simplifying the problem to see how we can use machine learning for this. In particular, this is a problem where we can use reinforcement learning. So I have, so this is, imagine you have a 3D printer. Today you have very sophisticated 3D printer which can stop and start at any point. But in general, if you have a concrete 3D printer, we have a problem because once you stop at any point, we have to stop the pump. Concrete has to stop pumping, otherwise the pressure will build up. And also when you start at a different location, if it takes too long to go to the other location, concrete will start setting and then you have a problem. So you have a lot of these problems. So in general, we want the path to be continuous. We start at some point and then it has to continuously trace the path and then complete it, then go to the next layer and so on. And so in the initial video from Netherlands, you saw that it was a continuous path which is desirable. So we take this particular problem. Let us say we divide it into number of cells, and we want to find out what is the path the printer nozzle has to take, so that we can complete this entire shape in a single pass. So the rules are the printer head cannot jump cells. So from one cell, it can go in the horizontal direction or the vertical direction, and not vertical, in the X and Y direction to the neighboring cell. So this is a simple exercise. We will do it after we come back. So we will take a break. We start thinking about this problem, and we will complete that exercise after we come back. Any quick questions before we break? This one question about whether fibers are used. Right now we are not used, but people have used fibers. People have already used fibers in 3D printing. Yes, we can do it depending on the type of the nozzle, the size of nozzle, the mix, and all that. We can use the fibers, but even fibers cannot take too much of tension. It is only slightly more than the tensile capacity of normal concrete. But with reinforcement rods, we go several times the tensile capacity of concrete. Any other questions?
Sir, I want to ask one question.
Yeah.
Sir, for multicollinearity problem, you said you give the analytical answer that the
Right.
singularity.
I saw the question I saw there's a question in the chat box. How do you do it how do you do regression when there is multicollinearity, right?
Yeah. You
Right.
give the
Okay.
you give the analytical answer to that. But
Right.
geometrically, can we say that the problem of multicollinearity actually leads to the higher dimension? That means it brings the problem to the higher dimension when actually problem is of lower dimension.
Right,
Can we say?
exactly. You have identified it very correctly. So what you need is really a dimensionality reduction. You need to reduce the number of variables. And it's not just a question of selecting variables from the original set of variables. The correct way to do it is using principal component analysis. You get a subset of variables in which you have maximum variation, and you use these variables for regression. Yeah, so you do, the answer is you do dimensionality the reduction typically using principal component analysis, and then you do the regular regression using the new variables which are the eigenvectors. Okay.
Yes, yes, yes. Okay, thank you, sir.
Okay. So we
Uh,
will, yeah,
just one last question, Professor
right.
Kenny. Is 3D concrete printing right approach for the construction industry?
Tell me again, if I understand correctly, is it the right approach for construction, right? Is that the question?
Yes, yes, 3D concrete printing.
Yeah. So to give you a very a quick answer, it is an emerging technology. It is still not in a stage where you can directly apply it. First of all, it is expensive. The kind of concrete we use for the mix we use for 3D printing is very expensive. You need special additives and all that. But when all technology starts like this, it is expensive when you start, but it is a very promising technology because manufacturing, they are already going into digital fabrication. So this is the answer to digital fabrication and construction, where you make a model and we have machines which can automatically fabricate the model. So it is a different philosophy altogether. So you are not constrained by the formwork, the kind of shapes you can cast and so on. So this is an interesting technology. There are a lot of challenges. I would say in another 5 years, we will know whether this is another passing fad or whether it will catch up. But this is definitely an area of research which we are working on. A lot of people are working on because they see this is likely to change the future. Okay.
Okay, thank you.
Okay, so we will start at 2 o'clock. You have quite a long break, more than 1.5 hours. So I suggest you also think about these problems. And on the website, you also see the lecture notes, the previous lecture notes. You can go through that. If you have any questions, we can take it up when we come back. Okay, thank you. We will meet again at 2 o'clock Indian time.